morning, sir. Good afternoon, sir. Yes. What is the contractor just told you now on site? He said that the finished use details have been sent to them. So I was like, so what was the conclusion for the originally we were planning to use EPM or TOA because this seems to be a very but it's not telling me that it's been one ending, so they have to go for economy. And those window type for WTC.
So that will be more circle.
Yes, sir.
And
yes, the frame is one ending. So I don't have all these details, so I don't know. We know this thing.
So you give us some questions. We have to focus on the major question that you give us. Let's focus on the major question you give us.
Alright, sir.
So the first one is just the definition of Morh circle. Got it. Then first definition of shear strength. In the second question, types of trouser tests and explaining with diagram. So we have
Hello? Yeah, I just spoke with my LSU. He said, check and bypass to him tomorrow. That is in doubt of that energy thing that they are talking about. So let us wait. And Lord, okay. And I don't need to see from you, and I will see from
so basically I'll just be drawing the diagram. We did the diagram, I need to explain the explanation of how the process is done.
Yeah, today is Saturday. I cannot really do it otherwise. But I will still call the guy because he told me the. Okay, I'll check. Okay, I'll check. What are we doing now?
Shear strength. So I'm now going into details of the shear strength. I'm just focusing on the question that I told us I are likely to see.
Okay.
So first is how to measure shear strength. That's different type of tests used for shear strength. And we have direct shear strength. We have the triangular test. We have the unconfined compressive test. So, and you just said it's the aid of diagram. I'll just explain the aid of diagram. This first one that I use is the direct shear. So these are the explanations. Yes, this is number one. This is direction.
Direction.
Yes. So in the explanation, we have the loading plate and the shear box. Inside the share box, the sample will be put there. That's the material that I want to check the strengths. So you put inside and it will be loaded.
Sorry, is that the sign for share? That's what I'm saying.
And then it's now.
Which one is top?
Just this.
Okay, that's up.
So, and the graph will give us, but I don't know if we need the graph in the exam. I don't know if we need the graph in the exam. This is top. This shares this one.
Load is being applied directly and
Yes. To simulate the environmental, that's sigma 3. And this one is the normal one, sigma 1. So you can get the details.
Is there any brief line of how to explain the diagram? I mean, the diagram. Like a short tips.
Just to explain that the sample is placed inside the share box.
You said what?
The sample is placed
Okay,
inside
Like the
the
sample, like,
yeah, the clay and the material. Get the share strength. It's placed inside the share box.
It's inside the share box. Okay.
And covered with the loading plate.
Share box.
Covered with the loading plate.
Okay, loading plate. Okay,
Then
the load is applied.
the load is applied. I just
I said the whole.
then
Yeah, it's no.
Okay.
then when at failure now, that's when we have the tau F. That's the shear strength of the soil. That's when we get the shear strength. Can I take? Yes, tau F.
Let me go.
Let me pass. This one is just a overview. The major thing is more circle.
Which one is that?
This one is the one. We are done with writing the document. Let me come back. Yeah.
Please start your answer.
Yes, sir. So this is the way the test looks like. But actually, what is actually happening is like this. What is happening in the material? This signal 30.
For the charger, right?
Yes, sir. So this signal 1 to signal 3 plus signal 2. So I think this is usually out. My friend was always talking about in class.
What
I
else?
will talk about
Some shock you, so you don't hear anything.
It's too low.
my voice is low.
Was it
Okay. Okay. So our signal 1 is the applied loading on this piston. That's the normal stress. And the normal stress is combination of the deviators and the what do you know? And the cell pressure. And the cell pressure. So this cell pressure is like the surrounding soil that is simulated here as water.
There will be discussions.
So it's simulated here as water.
But with the vehicles.
Yes, deviator. So that's the external load that is added from the top. So
That's his material.
yeah, that's
Not
not
two.
sigma 3 is the surrounding pressure. So that's like
2 is deviator.
no, 2 2 is deviator, 3 is set pressure, and that's what gives the normal stress. So from this Kaiser diagram, this one is our sigma
He
1.
said the material is operating for
Sigma 3 is cell pressure.
central. And sigma 1,
Sigma 1 is normal stress.
normal stress.
So this will now lead us to one thing that I always talk about, type of triaxial tests.
Types of stress.
And the UU, two, and the CU, and 3, and the CB. This one is unconsolidated and drain. On drain. Lens consolidated on drain. Lens consolidated drain. Trial tests is in 2 phases. We have the primary phase. That is the primary phase and the secondary phase. Is that correct? See, triangular test is in two phases.
Two phases.
Yes. You have the primary phase and the secondary phase. So we'll see this first line. This unconsolidated, consolidated. It is gotten from the primary phase.
Unconsolidated.
This one, the first one.
First one.
Yes, that's UCC. Yes.
On the first phase.
Yes, they are gotten from the first phase, that's the primary phase. Why the undrained or drained is gotten from the secondary phase.
I can't say it.
No, the first C now, the first C are gotten from the
Primary phase.
While the unconsolidated,
That's
consolidated,
the secondary.
the head
This one is
consolidated,
gotten from the
they are
secondary.
gotten from the secondary.
So this is in primary phase. If the valve, that's like the tap here, is open, then it is consolidated. Yeah, consolidated. When it is closed, it is unconsolidated.
If the
Yes,
the valve is
tap,
open,
yes, if it's open,
it's
it's
consolidated.
consolidated. This one, where the cell pressure is, if the valve and the water is allowed to drain smoothly, then it is consolidated. But if it is closed, that water remains inside. It is unconsolidated.
Okay.
So, why for the secondary now? If it is open for secondary, and it is open, it is drained. If it is closed, it is undrained. For the secondary, if it is opened, that's this one. This, when the loading starts, if this one that's from the material itself, from the cell membrane, if it is open, it is drained. If it is closed, it is undrained.
Okay. Two valves.
Yes, you have
One for primary,
one for primary, one for secondary.
So the one that is directly with the self and the
Cell pressure
reference.
is the primary. The one with the material secondary. So, like we was asking in class one day, if the first phase was open and the second phase was closed, what is it called? So if the first phase was open and the second phase was closed, it is what? First phase was open, consolidated, second phase was closed, undrained. That's consolidated, undrained.
I think that's the only way to pick the name itself.
Yes.
Speak louder as that.
Hey, Jesus. If the first phase is open and the second phase is open, it is what?
Consolidated drain. Consolidated drain.
Consolidated drain. If it is closed, open, then it's closed. If it is closed,
Close, unconsolidated,
undrained. So that's just the summary of that's just the summary of triangular test. Let me check everything. Then we can try to know the advantage over the direct shape. Actually, it is two basic tests. It is just the HL test and triangle. the third one is not usually used. So can I start to know the advantage? Let me check if you talk about that. Let's go. Trying to look at textbook for the advantage of trial test over the direct shape. That's what I will think based on the question that he asked, that he talked about. So let's now go to more sound.
What are the advantages?
Check them. I have only 3 here.
Tell us now.
Okay, let me list the 3 that I have. The drain condition can be controlled easily. That's yes, one of the advantages of trial test over direct shear. The drain condition can be controlled easily. That's and simulate what's happening in the soil when the real test is done.
The drain condition can be controlled easily.
Yes. Then number 2, pore pressure can be measured during tests. Can be measured during tests. That means you can easily get our effective stress. Then number 3, more uniform.
It's more uniform than
More uniform distribution of stress and strain can be capped.
More uniform stress.
More uniform distribution of stresses and strain.
More uniform distribution.
It has more uniform distribution of stress and strain when compared with direct shear. That's just the 3 that I have here.
That's the differences.
Huh?
That's the differences.
That's the advantage over direct shear. The first one, drainage condition can be controlled easily.
All pressure can be measured during the test.
Yes.
The more uniform distribution of stress and strain when compared with shear,
With direct shear. Yeah, drain condition can be controlled easily. So definition of shear strength. The instructors in class say that the tau F of a soil is defined as it's just the formula. That's
when you start that time, you make direct shear, trial shear.
yes. And the third one is not usually used.
What's the difference?
Okay. The third one is just like it's just same thing like this one, but it does not have a membrane.
And what's the name again?
Yeah, that's unconfined compressive test.
Okay,
unconfined.
Yes, unconfined compressive test.
fine.
It's also like this. Though it's not like, but the way you explain it, it's also like this, but without membrane. And this, it just does not take care of sigma 3. It assumes that sigma 3 equals to 0.
Because it's not, there is nothing surrounding it.
Yes. It does not take cognizance of sigma 3. So it's not usually used. All these things are not. It just, it does not have all this power.
The name again.
Unconfined compressive test. Unconfined compressive test. So let's quickly run through one sample.
Yeah, 3 minutes.
3 minutes. Jesus.
What do you want to do after this?
Okay.
Can we be watching and be teaching also?
No worries. What's happening
People
now?
are new.
Not choosing is choosing the right skill that matters.
But teacher more understand them so that we teach others.
Well, let's yeah, that. And most times when doing the class test, what are the use for it? So we have this stubborn formula and I always seen.
For more cycle.
Shearing stress. Shear stress or shear stress? Shear stress. So it's just like from our most sample.
Which formula is this one?
So these are our C. Just know it. And this square in this angle. This sigma, this tau. So when we draw more sample, this is what we are looking for. We are looking for our correction and angle of internal friction. So there are some situations where C equals to 0.
That's
Questionless.
sorry.
That's so in that case, our diagram will be like this. Yes, that's question. There will not be C at all. That's questionless. Like, yeah, that's so.
That is science.
Yes.
C0.
Yes. C equals to 0. So that's what we want to construct. So let's just make out our sets and our graphs.
We don't get to know.
You walk my class. Get out of my class. It's not okay, from the question you give us in the class.
But you don't have any exam condition. I saw one
Exam.
I have one question and follow from the exam.
So we tell it to this way.
Paper.
It's more something.
For one side.
For more something. Okay. Let's have it.
Yes.
Cancel that and maybe this week. Let's cancel it. Please be recorded. Check that off. Alright.
Yes. 1 hour.
Okay.
I should take 2 of it.
How will you take?
From the middle now.
Say that now keep the rest of it. And 6 people give you that thing. I don't propose. Wait, one of the
David said only use the 2.
I use it too. I don't
I don't cut down.
This is just like the one they give us inside the handouts. Like, it's not just like,
See, all those questions there.
Okay, sir.
I'm asking some support for class.
just like the question he gave us in class.
Yeah, I asked that.
Then, so, there are two soil samples obtained from construction site. In other words, on drain triangular testing using the following results.
Underweight on joint triangle test.
What would be the just do?
Okay, sir.
We have lateral head pressure.
You go carry that question.
Right, they'll give you now. Then there is pore water pressure, and there is the principal. Is 100, 300, 20, 136, 390, 83. So this is, you have those, you put sigma 3, this one is U, this one is sigma 1. So, I said something, I was explaining the shear strength. I said sigma 1 equal to sigma 3 plus sigma 2. What? Okay, I look at the assistant for. I saw one to the simple. Again, the question now, someone has the value of C and 5. 1. That is
What is C?
Position.
as it is with respect to total stress and 2 with respect to effective stress. So, and our effective stress equals to normal stress, power water pressure. So these are the basic understanding that we need just to draw. Please let's look at the name and just get the explanation. Is it lateral bed pressure surrounding soil? To that particular soil. That's why it's sigma 3. In some question, they can also give us deviator stress that has been applied. So that deviator stress is sigma 2. So sometimes they give us sigma 2 and sigma 3. They might not give us sigma 1.
So how do
You just add sigma 2 plus sigma 3. You get sigma 1 from this one.
Okay, now if sigma 3 is not given, then you calculate it and bring it out.
So,
If sigma 3 is not given, for example, we know the value of sigma 1 and you don't
And deviator stress.
and deviator stress. It's either they give you these two and they don't give you this one, or they give you these two, you don't need this one, or they give you these two and they don't give you this one.
Okay, but there will always be power water pressure.
Yes.
So if 3 is not given, you calculate.
So if 3 is not given, that means our sigma 3 will be equal to sigma 1 minus sigma 2.
That's what it is to get.
Yes. So then for effective stress, this is for total stress. For effective stress, our effective stress equals to
We said total stress equals to that thing.
Any total stress.
The first one.
Yes. It's just to get this. But if you want to get effective stress, that's when we use this one. Effective stress equals to stress minus core water pressure.
Okay.
So that's when we want to get effective stress.
Is that prime or one?
Huh?
Is it prime? Effective stress, is it prime or one?
This one is prime. So the first thing is for us to choose our scale.
How do you do that? How do you choose your scale?
I like doing that. What's the time? I need to eat out. What's 5 minutes?
I need something so we can find out where
I'm going to.
something. Too short now. Like if you see short, just see short press. I want the press say anything.
That is true. Okay, these are sigma. So what we are plotting against each other is sigma 1.
Sorry.
We are marking
we
sigma
need
1.
to put on the graph where the stress is and the sigma.
Yes, that's not what to pick from the graph.
And put this on the what? On the vertical.
This one is down.
Down.
So what we want to do what we want to map on our scale is sigma 3 and sigma 1.
What do you say?
What we want to map on our scale
Is
to
what
draw
are
the
the
muscle.
You are plotting was sigma 3 against sigma 1.
No.
Now against sigma 3. But what we want to draw here is sigma 3 and sigma 1.
Oh, okay.
So the left leg of your half is it half circle now what? Semicircle. The left leg is sigma 3, the right leg is sigma 1. So this is like the first test, another test on the same material. So the
What
first
do you say?
test,
Calm down.
You are rushing. No.
this is like the first test, that's this line. And this is the second test.
Yes. But you made mention that we are going to do it on different graphs.
Yes.
Especially for-
That's for total. You do total together, you do effective on another graph.
Yes.
That's it. So what we want to do next
Total, yes.
is after I finish it, I will start effective.
Can you use the same graph to do it?
Same
Well,
graph.
you
You can enter TID special.
Like, can take off.
Thing down.
You can plan it very well.
Yeah, you just have to plan it there. That's it. So picking your scale now, we have our maximum value here as 834.
We are working on total stress. So remember.
Yes, total stress. If you want to do effective stress, we minus. That's how we minus water pressure. But now, since you're working on total stress, use directly.
Okay. Yeah. Yeah.
So we have
834.
PG.
Yeah.
My phone is here. Let me check in case I get. In case they call me.
They call you.
My family members. So we have our maximum value as 834
Yeah.
and our minimum value as 100. So just pick between the 0 and 900. We have better to divide.
100 centimeters to
Now be like 1 centimeter represents 100
Units.
units. Say units. No, 100. What's the stress? Unity.
1 centimeter is small now, 2 centimeters.
Can you choose it? It depends on your graph.
2 centimeters. Represent 100, whatever. 100 meter, 100
So if you use 2
So,
centimeter,
2 centimeters.
Check it, it's 2 centimeters of the jet. That's anything. If you are using this figure, it's 1, 2, 3, 4, 5, 6, 7. Okay, you can get it here.
The standard is there now.
So you have 10, 20.
10K. You are going to 800 and something now.
Sorry, 100, 200, 300, 400, 500, 600, 700, and 800. Okay? No, sorry. 800, then you have 900 too. 900. So same calibration, we go for our y-axis. Same calibration, go for our y-axis.
What is the rest? What will be on your Y?
Okay, actually, it's also get. Let's look at for us to get this one plus this one minus this.
What are we trying to get?
300.
300 minus this 84 minus 300.
834 minus 300.
534. Do you have like
267.
267? That would be okay. That's the highest that will do.
How did you do it?
And so, wait, you say what?
You know what we want to draw is semicircle. And I'm looking at the largest one, that's the biggest value now.
That's 834 minus 300.
834, and you are drawing like this 300 to 834. You get to 834 around somewhere here. Right?
Yes.
So what I did was
Is it not 390?
39. No. It's this one and this one. This one and this one.
Wait, why wouldn't we do 100 and 390?
Yes, no, he's asking how do I get scale for the top.
Okay.
So the way the logic I use is just to get for the highest part. This one will always be smaller than the second one.
Yeah.
So if you minus this one from this one, you get 534.
Okay.
That's 534 is like the distance from here to here, the diameter. And what we just need is radius. So you just divide it by 2.
Okay.
Now, when you minus, divide by 2.
Yes.
Okay.
So to give us
267.
267.
Okay.
So you can measure 267.
Yes, it's 270. 300.
Yeah.
So you need to.
You can use IS of 300. But normally it's even more than that. Since you use you have 100, 200, you have 300, 200. So you know that you are not going above 300. There's no way you want to draw it.
267.
So let's since we have gotten that now, how to get our
Okay, if I have 267 as the radius, so I'll wait for my graph now.
okay, sir.
Please.
Wait, sir. Let's do for the small one first before the big one.
Okay, fine.
The big one that we did initially was just to get our scale.
Okay.
Though we still the same thing, we just use this 867.
Okay. So
So
this one will be 390 minus 200.
yes. Let's just draw. Okay. 390 minus 100.
100, yes. That's
That's
290.
290.
145.
145.
Yes.
So let's make 145 with our compass.
145.
That's the scale now.
Convert to our scale.
Uh-huh.
That's 2 centimeter represent 100. How would you know by this? That's
1.5 times 12.
1.45. If 2 centimeters,
Yeah,
wait, I'm coming. If 2 centimeters 100, and if we have 145, x equals to 145, Abi?
Yes.
So we cross multiply.
That is 2 times 145.
That's 2 times 145 divided by 100.
That is 2.9.
Also 2.9
Yes.
centimeter.
So those are
You have
our this thing. I measure 2.9 centimeter.
2 centimeters to 100. X equals 145. So 245. 145 times 2. That's 200. How much is it?
That's very 2.9 is your compass. So you put
145 multiplied by 2. Okay, 290. Divided
divided
by
by
100.
100. That's 2.9. So you very 2.9 your compass.
2.9.
So this is wrong.
Is you're picking up.
That's 2.9.
You're able to get the 390.
How will you do it? Okay, we'll still go to the graph and pick 390.
Yes, no.
Ah,
See now, 2.9.
Where's that?
Come on, check.
Where's that? 600.
One space.
I'll pick my 390. What am I supposed to do again? I'll pick 100 too again.
Okay, 2.9.
If I pick my 390, man.
Pick your 390, pick your 100.
Yeah.
Measure it. Measure what is there. In it of that calculation. What you are 100. Because this amount is with our normally to convert our 390 to this cube. That means our 390. So, yes, sir. Is your 100, is it correct? Your 100. So the graph is not correct. So what you just do is, oh, nothing.
See, this is 290. 2.9.
2 centimeters.
What's that 390 now?
Because I need this.
The graph is not correct. So the graph
And the
and the other side.
Well, you are playing it here now, okay? Now, can I go?
You know, very different.
This thing come. This 390.
Yes.
This 100.
Just come out of that. That's like
This is 0. 100. This is 0. So what am I to do next? I should not. He said we should measure 2.9 here. This is 2.9.
Just find it. Okay, then
Just find the. Don't worry about
This 5.6.
Normally, you do that on the graph of first, you calculate it.
That's 2.8.
They don't know one carry out. Maybe it's what JP said. I will just direct. PG. You know, just do paper. But you must have that. I think so. Oh yeah, oh yeah. Let's do the let's see you.
Okay, maybe.
Perfect.
So this is one of the serious students we have in class.
So my C is 1.9 on the scale. I multiplied by 100 again.
Another serious student. Say hi.
1.9. That's one.
That's 65.
You can now convert it to normal.
No, it's already normal like that now. It's 65.
I got this. If I measure this place to this place is 1.9.
1.9. That means the one is divided by 2 times 100 is what?
Times 100 divided by 2.
Yeah, divided by 2 times 100. Yeah. That's 95. Oh, sorry. Divided by 2. So you're on 65. No, 95. 95. The unit of stress now.
I don't know it now.
Stress is pressure, Newton per meter squared.
Okay. Kilonewton per meter square.
So if you come and use this one like that.
Where one can start?
What is it?
Now don't start now.
Okay, should I start again?
What's the unit now?
Kilonewton per meter square. All of now don't do the most half.
What is the answer?
Only 65.
Everybody
It's
cannot
only
get
95.
You cannot get anything now. Your constitution
You
is
should get
so you
it.
just
See the things are. His own is close to 65 soon.
So I mean like one.
How are you sure?
1.kilobar, man.
1.15.
That's 1.2. That's like 60.
Okay, I use the ruler.
That's like 60.
1 point. No, this is
That no position.
1.1.
Yes, you can do it.
1 point.
This 10, yes, this 10,
This is okay. This is
10, 20, 30, 40, 50.
60. That's 60. Or 65. Or 95. So,
Me question like down. Okay. She is this thing.
oh,
Well, 100 is not better, 0 10.
by the time you say 100 that time, shift your
You
your
start from
axis to the
0
back.
now. 0, 100. You now started from a 0.
So you have if you
You
shift
shift
to the back,
it back,
you go,
one
na
side
60
now.
you go get. So are we good to go? Anytime one nation.
She get it, but I
Okay, my this now is still coming.
So I think I got it start.
We'll do like NT and USRC. All time.
1.5.
Okay, the same process we do for effective.
I'm going to my judgment.
Yes, then you measure the angle.
Sorry.
They don't enter each other. They enter. Okay, they entered. So that means you are still going to do that of effective stress.
Yeah, so your angle just
The angle is next to
just horizontal line anywhere on this line. And just measure it with your compass. 23. So 23 degrees. And we have this one as
60, yeah, or 65. 60 kilonewton per meter squared.
So that's for total
I'm
stress.
not still getting it though.
It's not possible. What do you measure?
Maybe I'll just drop the line, go down.
What did you measure?
Still, they give me one something.
1 point what?
Count your graphs.
Count your graph.
Count your graph.
1.1.
1 point.
It's correct.
Correct. Divide by 2. Times 0 is 65.
Ah! Hey!
You will see yourself for
just
YouTube
like
there.
that's for total stress. Now, stress. The only difference between total stress and effective stress is just this formula that I wrote on the board. That's effective stress equals to total stress minus pore water pressure. So you remove pore water pressure from this one. From this one. You remove this pore water pressure from this one. From this one.
That would be 200.
So this one 390 minus 20. You remove 20 from it.
Yes.
You get 370 for this one. Then 100 minus 20.
Come on, you're rushing, I think. I don't understand.
This is effective stress.
Yes.
So
On a different graph.
Okay.
Yes, on a different graph. I'm just trying to, you have to see draw the table out for effective stress.
Okay, how do you do that?
When you use come.
Just draw the table. Sigma 3, sigma 1 for effective stress, and you just put this dot on top.
So kilowatt.
This thing gives us effective stress. So first one is 100 minus 20. This is the pore water pressure on that row affecting it. This 100 minus 20, it will give you 80. Then 390 minus 20 to give you what? Then for the second one, 300 minus 136. That's
You create another
164. Yeah, just better you just show what you are drawing.
Yeah.
164. Then 384. 834 minus 136.
Yes.
698. So actually, sir, also have the same. They are not going to be the same. But these are.
They are not going to be the same. None of it. Because by the time you do it, the two of it is going to come closer to each other. So it will become more, it becomes stiffer.
Yes, sigma 3 effective.
Okay, on top. Okay.
Yes, sigma 1 2 effective. So this is not the dimension that we take to draw our second Morh sample.
We have 100 minus 20 to be 80.
Yes.
Then
You have 390 minus 20, 370, 300 minus 136 to be 164, 834 minus 136 to be 698. So with that, we can draw our Morh sample.
Only graph from the accident.
And you can do it on the same
But not on
but
each
just
other.
different.
Yes.
Like, it's okay, I've decided.
Yeah, okay, I mean that. Yeah. Okay, we can.
The same thing, you want to do that one. That's the maximum to get your axis. Look at the maximum. And actually, if you want to do like, you can see the same scale, use the first one. Same scale. Yes. Just only be smaller than it. Just in the same scale. So that you don't have to be stressing. So if we use the same scale,
Yes.
just use 10, 20,
100,
200, 300, 400, 500, 600, 700.
When I get you this without now.
This one is 0. You have 100, 200, 300, 400. So with this one, you can mark 80. Just mark 80 and 370. And the way we did the first one, just draw it.
The vertical is still down.
Yes, down. Then the second one, we have 164. 164 should be somewhere here. Then 698. 698 should be very close to 700. So we have something like this. So that means is either we don't have C. Okay, we still have C.
So on this one now, the first thing is to get 80.
Yes, 80, 370.
80, 370.
Yes, when you mark both of them, just measure the distance between them.
Yes.
And try to locate the center.
370.
And try to locate the center.
And I have 80.
Thank you.
10, 20, 30, 40, 50, 60, 70, 80. So,
20, I think it's 22.
20.
You get them?
So,
Let's
Wait till you get them.
let's
this is 370. So, point in manager, manager.
I want to pass.
Yes.
I want to what saying.
Okay.
I'm seeing 5 here. 5.5. Let me just say 5.55.
5.5 divided by 2. And like 2.77. And like
This is 2.
yes, this 2.5, this 6.7. So you're between 780.
How do you go?
Then we take our compass from there. Before you go, just check. Just check it. If it gets to you. So yeah, so you can have draw. This way also. So the same process for the second one.
That second one is 164.
164.
164 here.
It's very close to 700. Almost on 700.
Don't mind, sorry. Motor, you buy 600. Will it 700?
How many minutes? 50. So you don't reach 1 hour when you start.
Thank you.
Very close to 700.
Yeah, almost.
Almost 700. Almost.
If we don't give up.
Oh, I'm going
I will give you the raw video. I will give you the raw video.
If you don't do anything,
5.25.
Calm down and shake your wall. Compass check here.
Yeah, I'm checking. What is the point?
Change the side below.
161. 161.
No, they go village.
For that.
So for that, that's so put down.
For that. Who is this check me, sir? 169. This is 110. 110.
169. Instead of 169, just use 170. Then down, instead of 698, you can just use 700.
70. One. Forget. Copy this place. Then instead of 690, I use 70. Who is this now? Hello? Hello?
Yes, sir.
It's 10.1, 10.1.2.
Get exactly. Have you shifted that exactly? Say, ma just okay, I go record myself later. Later.
Okay,
No.
5.15 cents. Wow. 5.15. Yes, ma'am.
Okay.
Oh, bring something else. Let's go program the record.
I'll correct back.
Okay. Okay, I will see you recording the video. So you guys wait till we finish this one.
So I see. I will get
Yes.
C like this.
It must touch the tool.
Mm.
Don't clear my boundary line.
One, this thing
One go zero.
go zero.
This is a
Then at 0.
Give her the small maybe.
Maybe very well.
But
I'm
you gotta have sound that suit like that.